Hi, this is Sholey Physics. We're talking about position time graphs today. Down in the description of the video, you're going to see a link to these documents that I mentioned here if you'd like to use them. I really recommend you follow along and do sort of a guided notes with this activity. So on a position time graph, there's a lot of information you can find out. In this activity, in this first guided notes piece, we're going to be looking at these various position time sketches and determine what kind of motion is being described in each of the sketches. So this is the kind of information we can find, which direction the object's moving. We're going to define that as a positive or negative direction. We're going to determine is the slope of the line constant or changing, so I'll talk about that. And number three, we're going to conclude what type of motion it's going to undergo. And there's 5 different motions here. There's an at-rest motion, a constant positive velocity, a constant negative velocity, or we might note that the object may be undergoing a positive acceleration or a negative acceleration. So those are the 5 different kinds of motions. First off, let's talk about the slope. What is the slope of the line? When you find a slope, you might recall from an algebra class hearing the phrase rise over run. So in that case, we're taking the rising axis and dividing by a change on the running axis. So what is on the rise axis here? It's position. So the rising axis, when we think about the change in y over change in x, which is also the y2 minus y1 over x2 minus x1, those are all different forms that people often remember from slope. So what is the change in the y? That little delta symbol, that triangle, means change. Change in the y is a change in position. So we are talking about a change in position divided by a change in the x-axis, which would be a change in time. So if we pick any 2 points to find the slope of a line, you pick 2 points on the line, you think about the rise divided by the run, which is the change in position divided by the change in time. X being position and t being time, that's what it is. So in physics, what is a change in position over time? It's the velocity. Specifically, it's a displacement over time. So it's the velocity. Okay? So on the slope of a position time graph reveals the velocity of the object. Take any 2 points on any line segment on any of these sketches we're going to look at today and do a rise over run, you get the velocity. So velocities can be positive, they can be negative. It gives a sense of direction. So if I say my forward facing direction is positive, that means my backward facing direction is negative. I can go forward or backward, positive or negative. So velocities can be positive or negative. How does that show up on a slope? Well, slopes can also be positive or negative. So it translates quite nicely. Slopes can also be zero, a zero slope, or you can have a kind of a slight slope or a steep slope. So the value of the slope gives you the value of the velocity. So that's what we're going to see here. All right, in this first one, let's look at the example real quick. First, we're going to determine what is the direction. Now, I'm going to call, just like on this graph here, if we go up the graph, up the y, we get a positive change. So this first graph is showing a positive change. As time goes by to the right, the position is increasing. So that's a positive direction there. There's a positive change. This object is moving in the positive direction. What kind of slope is this? Is it a constant or changing slope? So down below you'll see a few slopes here. The slope on this part of the graph is the same as the slope later on. So this is a constant slope, just like in the example. This would be a changing slope. In the beginning of this graph, there's a steep slope, and later on it's lesser. So it's the angle decreases of the slope. All right, so that in this example, this is a constant slope. The slope at the beginning is the same as the slope angle in the middle, is the same as the slope at the end of that segment. And finally, we're going to identify what is the type of motion. Is it at rest, constant positive or negative velocity, or positive or negative acceleration? So in this example, the slope of this line is constant, and the slope is the velocity. So if the slope is constant and the slope is positive, then this is a constant positive velocity. And that's how we can identify that. So that's the steps we're going to take here for each of these graphs. All right, so in this first one, what is the direction? Is it a positive change or a negative change? It's no change at all. There's no direction here. The position is not getting greater or lesser. The position is staying the same. So this is a no direction at all. Not trying to trick you there. It's not positive or negative. It's neither. So number 2, what is the slope? Is it constant or changing? This slope is a constant slope. It stays the same. Now, what kind of constant slope is it? Because we can describe it a little bit more here. If you recall that a flat line or horizontal line from algebra is described as a zero slope. So I'm going to add that little detail in here. This is a constant zero slope to describe that slope. And therefore, if the slope is constant and zero, then the velocity is constant and zero. So how would we describe that as a type of motion? At rest, constant velocity, or positive or negative acceleration? While it is a constant velocity, it's not positive or negative. So what's the best descriptor here? At rest. This object is at rest. And we can look at the data, the numbers specifically. The position stays the same. So that also agrees with a zero slope. The object is not going anywhere. It's staying at the same position as time goes by. Next one, let's look at the direction. Are these values changing positively or changing negatively? As time goes by to the right, remember this axis moves to the right, that's the direction. We're going to read from left to right. The values are decreasing. So this is a negative direction motion. Now we'll look at the slope. Is the slope constant or changing? This is a constant slope. Happens to be a constant negative slope. So if the slope is constant and negative, then the velocity is constant and negative. So the best descriptor here is a constant negative velocity. Write that down. All right, it's not getting faster, it's not getting slower, but it is moving in the negative direction at a constant speed. On our third one, changes a little bit here. As time goes by, what's happening to the position? The position is increasing. So this is a positive direction of motion. All right. What about the slope? The slope begins rather steep and later on is lessened, and near the end it's almost a zero slope. So this is a changing slope. That means if the slope is changing, the velocity is changing. So we need to think about how the velocity is changing. It's moving in a positive direction, but the slope is becoming less and less and less. So this is what direction is the acceleration then? In this case, the velocity is not remaining constant because the slope isn't constant. So we're moving on here to deciding if this is a positive or negative acceleration, a positive change in velocity or a negative change in velocity. So if these slopes are becoming less positive, they're becoming more negative. So this would indicate a negative acceleration to the motion. Okay, so I want to take a break here just to quickly help you run through what we just talked about. This would represent no motion, at rest. No motion, positive motion. All right. This is a constant motion. This is also a constant motion. This is a positive direction and a negative direction. Constant positive velocity, constant negative velocity. Okay. And finally, this is a constant motion, constant speed. Here's a changing speed. These are both in the positive direction, but this one is remaining at the same speed. This one is increasing its speed, becoming more positive. Okay, so we'll come back to those in a moment. Just want to do a check-in there. Check-in. All right, moving down to the bottom. We've got some more changing slopes here, so let's look at how they're changing. In this next one, what's happening to the direction of the motion? It's moving forward. The position increases. So this is also a positive direction and a changing slope. Look at that slope, it's curved. So this is a changing slope. It's not a straight line, it is a curved line. So the slopes change. So then we think about, okay, the slope's changing, so the velocity is changing. How is it changing? Is it becoming more positive or more negative? In this last example, the slopes were becoming less positive. In this one, the slopes start out small and become steeper. So the slopes are increasing here, becoming more positive, okay? So this is a positive acceleration. Since the slope increases, the velocity increases, becoming more and more positive velocity. In this next example, the position is decreasing. This object is coming back to the origin. Here's the origin. So since the positions are decreasing, the object is coming towards the origin in a negative direction. Throw a V in there. Okay. But also the slopes change. This is not a straight slope. This is a curving slope, a changing slope. So how are these velocities changing? The slope is changing, so the velocity changes. The slope starts out kind of small but negative and becomes steeper and more negative. Do you hear that? So even though it's getting faster in the negative direction. So since the slopes are becoming more negative, this is a negative acceleration. Negative acceleration doesn't always mean the object's slowing down. If there is a negative acceleration in the positive direction, then it's slowing down. But if there's a negative acceleration in the negative direction, it's becoming more negative. It's getting faster. You see that? Hope that's not too tricky. As we move through these examples, I think you're going to be able to see that more and more. And a last one. Positions are decreasing as well. They're becoming more negative. But you see that the curve is a little bit different. So what's happening here? This is also a negative direction, just like in the last example. And it's also a changing slope. But how is it changing? So we start looking at the beginning, towards the left side of the time. Time goes by, we flow to the right. So in the beginning, there's a steep negative slope. And towards the middle, it becomes a lesser negative slope. Did you hear that? And towards the end, it's almost stopped. The slope is almost zero. So we're approaching a zero slope. That means we're approaching a zero velocity. So how is it changing? It started out with a lot of negative slope and it becomes less negative. So if this is becoming less negative, it's becoming more positive. This is a motion in the negative direction, but with positive acceleration. All right? So that's a positive acceleration. So here we're going to run through these one more time. We have at rest, negative motion, negative constant motion, positive constant motion. To be more specific, this is a positive constant velocity, negative constant velocity. Positive constant velocity, positive acceleration. And finally, we have a negative acceleration. See how the slopes increase? Here the slopes decrease over time. So this is a positive change in velocity and a negative change in velocity. All right. And finally, I want to make one more sketch for you. What would these graphs look like if I paired the negative acceleration from, let's see, this graph? All right, see, this is negative acceleration. What if I continue this motion with the other negative acceleration graph? Do you see how this is, if we put these two together, they'll form sort of a rainbow. So what if I just sketch that on here like that? This motion is a negative acceleration. You know what? If you toss a ball upward with a negative acceleration due to gravity, and I'll put a negative on there, all right? Throughout the ball's motion, there's a negative acceleration, so that ball slows as it goes up, and then it gets faster as it goes down. There it is. That's the motion of a ball when you toss it. So as it goes up, there's negative acceleration, and as it goes down, there's also negative acceleration. So what's it do? It starts out fast as you toss it upward, becomes slower and slower and slower, then its vertical motion stops before it starts coming back down again, and it gets faster and faster and faster. So what happens with a positive direction and negative acceleration? It slows down. What happens with a negative direction and negative acceleration? It gets faster. Right, but faster in the negative direction. Hope this is helpful. The next thing we're going to do is move on to movie graphs, and this is a thing you're going to work on. So we're at the end of the video here. So what I'd like you to do in this activity, this is going to help you piece all these things together. These are several segments put together, but I don't want you to talk in physics jargon here, okay? You don't really need to say like positive acceleration, constant negative velocity. But let's use some stories. Let's tell a story here. Can you get a story from these graphs? So can you turn these motion graphs into a movie? If you think about a movie, how movies used to be recorded, they're recorded by taking a series of pictures. 30 pictures per second was a common frame rate. So if I put 30 pictures together and flip through them in 1 second, our eye won't be able to tell the difference. But what is a movie but a series of pictures where you're seeing objects move in the frames? So the object was here, and then here, and then here, and then here. If you ever made a flip book with little stick figures, you can flip through that book and it looks like the stick figure is actually moving. So that's what we're looking at here, the position time graphs. So if we give a label to a graph, then we can make a movie out of it, a little scene. So Jessica running the bases. So this is a position time graph, so we see a constant positive velocity and then a constant positive velocity, but the slope is less. And we see an at-rest kind of motion. So how can we interpret that? Well, she's running the bases. She must be running fast and then slows a little and then stops. Why might she stop? Well, if she's running the bases, she might stop on one of the bases. So I have Jessica runs toward the bag, slows a little, and stops. Here's her running. She slows and she stops. That's the example. So for the rest of these, be creative, have some excellent fun stories, make them up. What happens on that car ride to school? So think about the motion in the beginning, then something happens here in this car ride to school. And then we have some more motion here, but look, this segment is less steep than this segment. So what might happen to show a change, make something up there. And we are going to school, so I wonder what happens at the end here. This next one is a student walking the halls. A lot of crazy things can happen in the hallways as you're going from class to class. Here's a ball bouncing and a yo-yo. Now compare these. The motions shouldn't be very, I don't know if there's a lot of story to tell here. But if you look at the curved nature at the top and the bottom for that ball bouncing, it's a little bit different than when you're tossing a yo-yo, when you throw it downward and yank it back up. So that might indicate that the sharpness of these changes here might be from that, how you throw a yo-yo. And finally, 5, this is a good story one. I always get good stories from the pizza delivery dude. So what can happen in the pizza delivery dude's motion here? Now be real careful. Check them over once you're done writing the story. Refer back to what's up and down. Like if you see this kind of motion, it's supposed to be at rest. So does that agree with these segments in your story? If you see this kind of motion, what is it? Just check back over your work when you're done. And I hope you have a good time writing the stories. Make sure you submit them online.